Hello and welcome to today's webinar on Diagnostic Imaging and Medical Solutions with Xilinx FPGA and Adaptive SoC powered system on modules. We are glad to have you here for this informative session from iWave, Xilinx and XLPoint and appreciate you taking your time off the day. A few housekeeping rules regarding the webinar. This session is for a duration of 1 hour and all participants are on listen only mode. This webinar will be recorded and a copy of the recording will be shared across to all participants. Please feel free to post your questions on the chat window. We will do our best to answer them immediately or take them up during the Q&A session towards the later part of the webinar. We have a packed agenda ahead of us, starting with an introduction and overview of Xilinx, then the Xilinx product portfolio for medical solutions and a few architecture examples, and a run-through of the Zynq and Zynq MPSoC powered system on modules portfolio from iWave, highlighting a few case studies and the value-added expertise around the system on modules, and ending with the Q&A. So without further ado, we'll get started with the session. Over to you, Aditya.
Hello, and welcome to another webinar from iWave, Xilinx, and XLPoint. My name is Aditya, FAE at Xilinx. Thank you all for joining us today. In today's webinar, we will walk you through various implementations of FPGAs and programmable SoCs in the diagnostic, imaging solutions, and medical devices market. In the recent times, the medical market has gone through so much of change and increase in demand due to the ongoing global pandemic, which is why this topic is so important at this juncture. Xilinx has been serving the medical market for a long time, and in today's session, we will take a look at some of the key trends and applications in the medical segment. We have a packed agenda, so let's get started. Up first, we will have Shubh Bhattacharya, who is the lead healthcare and sciences at Xilinx. He is going to be walking us through some of the key solutions in diagnostic imaging and medical devices. Followed by Tawfiq Ahmed, who is the product marketing manager from iWave Systems, who will walk you through some of the interesting SOM-based solutions and capabilities for faster design cycles, as well as a few success stories serving the medical market. But before that, let's dive in a quick introduction on Xilinx, its key markets, as well as its products. So as some of you might know, Xilinx was the inventor of the first FPGA back in 1984, but we've come a long way. We have offices all over the globe, and in fact, we have one of the largest engineering sites in Hyderabad as well. So that gives us a lot of unfair advantage for customers here in India, working closely with the design teams in Hyderabad. We have close to 5,000 employees, about $3.15 billion of revenue in FY21, 60,000 plus customers, and a lot of patents in our name. Our solutions span across various different markets, as you can see. Recently, we've been working a lot on the data center space, but our traditional businesses have been around wired and wireless, aerospace and defense, industrial test and measurement markets, as well as the automotive, broadcast, and even the consumer market. As you can see, the industrial vision, healthcare, as well as the aerospace and test and measurement markets are one of the largest markets that we have today in Xilinx. Xilinx created our first FPGA in 1984, and ever since we've been innovating right up to the latest solution from Xilinx, which was our first SOM module, an embedded SOM module in 2021 called the Kriya SOM. We've also been focusing a lot on the data center market with our accelerator cards called Alveo, and back in 2012 we launched our first SoC as well. Right. So innovations in SerDes, in larger capacity FPGAs, in SoCs, and then finally even in the SOM market. Now, as I mentioned earlier, you might have seen a lot of various devices that Xilinx has been innovating on, but I wanted to focus specifically on the 16 nanometer UltraScale plus FPGA and MPSoC platform. In the recent past, we've also introduced some newer devices that you've probably may or may not have come across called the Artix UltraScale Plus cost-optimized FPGA portfolio, as well as a newer device called the ZU1 in the MPSoC portfolio. Um, Apart from the devices, some of the key trends in the industrial medical market are, connected factories and hospitals, smart cities. A lot of work has been done on machine learning for cameras and predictive maintenance solutions. We'll talk about many of these interesting solutions specifically targeted on the medical market. Xilinx is also focused on adaptable intelligent factories and cities. So starting from robotics to control drives to PLCs, IO modules, graphics for panels. In the railway segment, a lot of focus on surveillance, video, security, vision market. So these are some of the key markets in the industrial segment that Xilinx focuses on. So one thing which I wanted to emphasize a lot, especially for this market, is the Zynq and the Zynq UltraScale Plus portfolio, as I mentioned earlier, primarily the SOM portfolio. So this has been a really successful product for Xilinx, right? And we've seen a tremendous growth in the recent years, and that's the reason why we continue to build on this particular platform for the most part. Xilinx has been focused a lot on the industrial and healthcare markets, whether it is longer life cycle of the devices, production ramp rates, especially in the healthcare market could be anywhere between 3 to 5 years. Extended temperature ranges for the devices, especially in industrial and medical and aerospace and defense kind of applications. We have a track record of very high reliability in our parts, and we ensure that this is also supported to our healthcare customers as well. And finally, most of you might have been following the news on the acquisition of Xilinx from AMD. So together, Xilinx AMD will become the industry's largest high-performance computing leader, right? And we focus on growing these diversified markets that we spoke about earlier together. Together, we will have a very strong portfolio for these various markets, including the embedded market, in which we will continue to focus on medical applications as well. Without further ado, I would like to now pass it on to Shubh. Shubh, please take it away.
Thanks, Aditya. Hello and welcome everyone. I'm Subh and I'll spend a few minutes today talking about Xilinx's presence within medical devices and healthcare. But first, let's start with the worldwide view of the medical market dynamics. The course of healthcare changed, as we all know, with the advent of a very unexpected event, the COVID-19, and I'll talk a little bit about COVID-19 impact shortly. But in general, first, as we move into 2022 and beyond, the aging population is projected to grow vastly from 23% to 32% by 2050 worldwide. Now, this growth is driving the need for better medical devices that are safer to use. Now, older people have more chronic symptoms, and healthcare networks are working fast to increase the number and capacity of systems they have in the hospital, but also systems that can leave the hospital and be used in the field for point-of-care applications. Secondly, growth of the emerging markets is increasing competition, cost pressures on medical device makers. In the past, large medical companies in the US, they enjoyed complete market dominance. Today, it's a very competitive market because many medical systems are simple to build from a technology point of view. Now, human bodies are slow, so interacting with them doesn't require a huge amount of performance. But because of a low barrier of entry, new investments, many smaller devices are emerging and increasing the pressure on the established market to create cost-competitive and compelling products. On top of that, government-sponsored healthcare programs, additional tax burdens, and the requirements to bring healthcare costs down from your customers, the hospitals, the insurance companies, they're all creating cost pressures on medical devices. Now, requirements are increasing to make medical devices smaller, portable, battery-driven, targeting more point-of-care applications. Also, medical devices need to move with patients between rooms and be able to assist doctors and nurses in the field, thus creating a decentralized healthcare networks. But all those need to be achieved without compromising patient safety, which means designing a safe, reliable device and to satisfy the regulatory requirements. Here's shown a survey of CEOs and COOs of major medical equipment makers in the world, and it reveals the regulatory challenges to be one of the top most identified issues, a staggering 44% as shown in the chart at the top of this slide. And this is because most regulatory rules can be complicated and involves many external factors. The most important thing is to demonstrate to regulatory bodies that medical systems are low risk and high reliability at the same time. Failure conditions are predictable, risk is well managed. So getting stuck in a regulatory process costs a lot of money and perform additional verification, validation, testing, and increases your time to money or market. So Xilinx is a key supplier to the healthcare and medical equipment industry for being many years like that. Today we're in most major applications using our embedded electronics with our SoC devices and our FPGA devices. Now, Xilinx innovative adaptive compute platforms are adding value to the variety of modalities, including medical ultrasound, digital X-rays, CT, MR, PET scanners, diagnostic imaging, and surgical and other clinical equipment as well. Now, we're clear market leaders in semiconductors in ultrasound, endoscopy, robotic surgery. Areas like dental imaging, patient monitors, defibrillators, smart beds are growing fast for us. But what about COVID-19? I mentioned this earlier. We know COVID-19 has impacted the world in every possible way. And let's see how it has impacted healthcare space and how it can change things in the future. So we saw COVID created a significant surge in demand of hospital equipment like patient monitors, ventilators, as well as in diagnostic equipment. It also slowed down elective procedures last year, but almost back to previous levels now, with slight ups and downs with Omicron and other new variants coming online. But longer term, the impact of COVID, both on the market and on us, we believe would be accelerated adoption of new and emerging applications in telehealth, remote patient monitoring, and point of care therapeutic and diagnostic services. Additionally, we'll see an acceleration of AI applications in healthcare impacting the entire human life cycle. So let's talk about some new challenges within the point of service medical devices. Healthcare applications, they now demand a lot more and is presenting new challenges. And for next generation medical devices, in endoscopy, for example, while we have achieved with our SoCs low to almost zero latency, sub 50 milliseconds and so on, improved ISP capabilities and supported multiple high definition simultaneous displays, we're now looking at growing demands for high resolutions to 4K to 4K 3D and even 8K, along with the use of machine learning algorithms to assist specialists and surgeons in making accurate and critical life-saving decisions. As medical ultrasound continues to grow in a wide range of applications for its non-invasive nature and for its ability to see soft tissue images, there is a growing demand in supporting advanced imaging techniques in beamformers, in multidimensional visualization, and to apply artificial intelligence to assist in diagnosis of critical ailments. At the same time, equipment like this has to be protected from cyber threats, needs to be safe to use, and needs to fit its energy envelope and be practical from the cost perspective. So similar challenges need to be addressed for clinical equipment as well. So here are all our products, our pure FPGAs, our SoCs, starting from their 7 series, 28 nanometer products to our newest family called Versal in 7 nanometer. The horizontal bar in the center, as you see, like basically all of them show the different applications, like what products really apply to edge applications, RF, cloud, and broader set of applications. A new product line has been added to the lower end of the Zynq UltraScale Plus MPSoC family, the ZU1, along with the existing ZU2, ZU3, and up, and comes in variants of the CG, the dual core, or the EG, the quad core, along with the GPU, along with the Mali GPU. There's also, and you see this wider set of applications here in terms of clinical equipment, all the way, like a lot of the examples I mentioned below, along with other vision industrial type applications as well. There's an entire new family added also in the cost optimized portfolio in the pure FPGA, the Artix UltraScale Plus, that was introduced back in March of 2021. With the 4 new devices, and the first 2 of them are available today. And there's also a new package, the integrated fan-out info packaging. So as you see in healthcare applications, depending on high-end, mid-range, edge versus other applications, and basically all our products kind of map into the healthcare sections in the different parts of the market. So kind of delving a little bit more into the applications, here actually you saw a previous slide, our newest generation of products in this 7 nanometer Versal family. Now Versal is our adaptive compute platform with closely coupled multiprocessor system, the programmable logic fabric, and the new intelligent, or the AI engine with the highly parallel tiled SIMD VLAW architecture. SIMD stands for single instruction multiple data, and VLAW is very long instruction board. It allows you to implement very high data rate algorithms, for example, in parallel software beamformers, or for 3D or 4D visualization, for AI, machine learning, inference for region of interest selection, for example, or for surgical tool guidance, data inference assistance in radiology, image reconstruction offload in in radiology, as well as in robotic surgery, endoscopy, all these applications, using a fully embedded device, and you can go ahead and replace some of those GPUs that you have in the system. So moving along, the best silicon, they do need to come with capable tools and methodologies. So we're enabling platforms to be accessible by all developers. The key to unlocking the power of adaptable hardware software technologies is to make them accessible to hardware and software designers. And we do that by providing platforms in their familiar programming environments and habitats. And reaching all developers means we continue to serve hardware developers, embedded software developers, and build new layers on our solution stack for application and AI developers. In short, there are multiple entry points or on-ramps into our platforms. With Vivado, if you're familiar with the Vivado toolchain and Xilinx, we introduced the industry's first plug-and-play IP integration environment, where you can work at the interface level and not just the signal level of your IP building blocks to put together a system intuitively and quickly. Now, with the Vitis unified software environment, we enable C, C++, Python, System C, OpenCL, and with Vitis AI, we enable the AI developers. So now let's look at a few example designs in clinical applications like endoscopy, ultrasound, patient monitors, etc. So here's a example video endoscopy system. Endoscopy system typically has a processing system consisting of a light source and a camera head, a camera control unit or a CCU unit, and an image management unit. The image sensor, like a Sony or an OmniVision on the camera head, performs the image capture, and the image signal processing can be done using, for example, our Zynq UltraScale Plus FPGA. The video streams are then fed to a series of cascaded FPGAs like the Zynq UltraScale Plus MPSoC is an example to perform image pre-processing, and the streams are displayed near real time using a DisplayPort or a quad HDI interface to high definition monitors for the surgeon to view. The camera control unit performs picture, color, noise corrections, including white balance, automatic brightness control, gain control, iris control, etc. There are different ways to partition the pre-processing functions depending on your architecture. As part of the post-processing, various image management functions are performed on the raw video using an SoC like the Zynq UltraScale Plus MPSoC EV versions with built-in video codec engines. Now, of course, all of these could be substituted using the system-on modules that our partners provide as well. Now, this is an application example of implementing machine learning in ultrasound applications. Here's a use case for one of our first medical customers in the US to go to production with a machine learning inferencing engine using the hardware on a Zynq platform, moving to a Zynq UltraScale Plus MPSoC in the next generation. It's performing an automatic kidney bladder volume analysis using a handheld ultrasound probe. Such is the efficiency of this machine and its technique, it has been approved for use by nurses, and it has brought big productivity improvements within a cumbersome clinical procedure which used to take a lot of time. This application can and will be extended to automatic anatomical geometry measurements in the future. Other applications in similar area. The Xilinx SoC for ML and ultrasound was chosen for its low power and thermal envelope, the low solution cost overall for BOM, the device longevity, lifecycle support, edge inference with the low latency, and integrated solution without data movement outside the system. So here's one more example of the patient monitors, multi-parameter patient monitors, bedside monitors, monitor, defibrillator integrated. I mean, it really applies to all those equipment. So patient monitors, they talk to a multitude of sensors at a pretty low amplitude. They require very low power dissipation most of the time because primarily there's a need to run on battery backup modes if needed, and monitors are moved around in hospitals quite a bit. Now with the Zynq family of Xilinx processors or Zynq UltraScale Plus MPSoC solution, or with the system on modules, you have all the right IOs, including USBs to HDMI to big display. You have the separate power domains, which is unique to the MPSoC, 3 different power domains for safety applications to separate your critical medical code, for example, from the application processor. You have dual redundancy possible for criticality. The R5s can be its own power domain, the FPGA can be its own power domain, and an arbiter monitoring the two. If, for example, the A53 ARM processing cluster goes down, the R5 has redundant data, for example, in that system. So you can shut down the system without losing critical medical data. The other thing that is enhanced in the MPSoC SoC family is the cybersecurity, which makes it easier for you to sell to the hospital IT administrator. They don't want an endpoint to become a liability in their network. They don't want to go inside the system to maintain it. They don't want to. They don't need they don't want the need to go inside to maintain, and also over-the-air updates are also a major advantage. So you don't have to access valuable cycles sending your crew to each and every hospital your equipment is maintained in. So all in all, these are examples. I mean, there's many applications that we're in. A few of the things I wanted to bring up here, like the endoscopy, ultrasound. There's, with the Versal device, for example, we have now a full-fledged parallel beamformer that's implemented as a software beamformer on the Versal AI engine that I mentioned, the intelligent engine. We have a demo on that. But there's a lot of advanced solutions we're developing for the medical world. We're all actively working with our partners like iWave and others on developing system modules for faster time to market with better software support. So yeah, there's a lot of choices going forward. So in conclusion, from my side, we have I wanted to mention that we have a large presence within the diagnostic imaging in particular and medical devices in general, with all the right tools, software, platform, and the partner ecosystem for the best solutions and for rapid time to market. Our scalable SoCs and SOMs provide the required integration, real-time processing, and the set of IOs to target the right BOM cost, performance, scalability, and design reuse. Along with that, the reliability, tools, certification compliance, long life support, which by the way is 15 plus years that we certify. I mean, but we're known to support 25 years if required for both our medical market as well as other high reliability markets like aerospace, defense, and so on. So that makes Xilinx and its partners building our SOMs and our ecosystem partners are ideal for your medical device needs. And with that, I would like to hand it over to our partner Taufik from iWave for the rest of the presentation. So thank you very much for your presence and attention today.
Thanks, Shub, for the wonderful insight on Xilinx products for diagnostic imaging and medical solution with a few examples on the case studies. So my name is Taufik and I'm responsible for product marketing at iWave Systems. Thanks for joining this webinar. So to give you a quick background about who iWave is. So iWave is an embedded engineering company established in the year 1999 with the primary mission to be a embedded technology partner to companies across the globe. Over the last 22 years, we have built strong embedded engineering expertise over various embedded platforms and have enabled companies across the globe in their product design, development, and manufacturing journey through their life cycle. We have established a complete design and engineering team is in Bangalore, but a very well supported distribution and manufacturing ecosystem across the globe. Looking at the iWave XILINX partnership over the years, we started in the year 2003 as a pure play engineering services partner to companies, helping them on their hardware carrier board design or in terms of hardware product design, their RTL and complete software development. And over the years have transitioned more to a product oriented organization, building a strong portfolio of Xilinx powered system on modules ranging from the Zynq 7000 to the ZU19. And we also have a strong product in a roadmap for 2022 and 2023 with the XILINX RF-SoC, the Kintex UltraScale Plex, and the Vertex UltraScale Plus system on modules later this year. So diving back into the key topic of this webinar, the key challenges in medical product design. So recall and quality issues are a main consideration in medical product design, which needs to be taken care from an engineering, testing, and validation perspective. So while looking at a brand impact, recalls were the number one criteria which majorly impacted a brand over the years. Looking at regulatory challenges, we all know that medical product regulation and compliance is one of the most complex processes across the globe. Whether it's the ISO 14971 or ISO 13485, compliance with government and industry regulation remains a constant weight for medical device designers and developers. Regulatory bodies as well struggle to stay up to speed of market. Medical devices are always subject to strict safety standards and usability guidelines. One essential consideration is thermal management, in which the IEC 60601 standard regulates the surface temperature for medical devices. Therefore, thermal simulations are an integral part of the design process. Technology, innovation, and time to market. There are startups coming up every day enabling new and new products focusing on software, AI on the edge, and more embedded computing power on the edge. Therefore, it is important to implement an efficient and high quality R&D process for medical companies to comply with the strict regulatory demands, which can help them realize a rapid time to market. So this can definitely be the decisive factor for medical devices as of today. And last but not the least is in terms of life cycle management. We all know that with this regulatory compliance, medical devices are in the market close to 10 to 15 years, where you need a strong supply chain with ensured product support and longevity. So the supply chain is definitely one of the key considerations in medical product design. And looking at the MPSoC or the adaptive SoC, it is quite complex. The design includes complex power circuit design with associated power sequencing and higher power density per area. The adaptive SoC or programmable SoC design encompasses complex design challenges which require a highly skilled engineering team. A few of the challenges include the complex I/O banks voltage handling, or the high-speed DDR memory design, or in terms of the layout design for SerDes lines up to 58 Gbps. And all this has to be done with form factor constraints, which also include the thermal management. So how does the system on module address the adaptive SoC design challenges? The system on module incorporates all the above design considerations, which helps customers to focus on their core competencies and features, and drastically helps them reduce their time to market with reduced development cost and risk. iWave systems and other system on module manufacturers alike take responsibility of product longevity while maintaining end of life for the hundreds of components on the system on module. So starting from the feature-rich system on module, which integrate the peripherals required, to the product longevity support in terms of the supply chain as well as in terms of DSP updates, or in terms of future enhancements, or in terms of reduced development cost, risk, and time. The system on module helps companies address the design challenges with the MPSoC or the programmable SoC. And how does the iWave MPSoC system on module help solve the challenges faced by a medical product designer? So the first consideration being the reliability. During the design of the system on modules undergo rapid and various EMC compliance tests and several rugged tests such as thermal cycling, aging, stress, and other various mechanical tests. This ruggedness allows adapting the system on modules to the product with ease and assured performance, with giving the designers assurance on quality and performance over the years. The module vendors also provide good technical support in integrating modules into customer systems while providing hardware, FPGA, and hardware customization services. The next point being in terms of scalability. The system on module approach for the adaptive SoC allows great scalability for end application in terms of logic density, FPGA IOs, or in terms of number of transceiver lanes. For example, a well-designed carrier board architecture can cover system IO ports from multiple end products ranging from the ZU4 with 192K logic cells to ZU19 with 1.1 million logic cells. The system on modules approach also allows migrating new generation SoC solutions without changing the product mechanical architecture. Longevity, which is the key consideration in today's world. So with a strong sourcing and supply chain team and also a strong roadmap on the BSP updates, iWave ensures product longevity or system on module support for a period of 10 to 15 years with no worry. Therefore, companies who are designing with our system on modules and getting the certification through the regulatory bodies can be assured of no change on the for a period of 10 to 15 years. Similarly, through our strong sourcing and supply chain team, we are able to maintain a continuous forecast and supply to customers irrespective of the the current supply chain strain that is happening in the market. And last is in terms of customization. So where we have the enable companies to customize the carrier card as per their requirement, and there's no need for customers to compromise on their form factor, mechanical or thermal requirements. And there's absolutely no restriction on the peripherals usage on the system on modules. So medical devices are amongst the most highly regulated products, as you might be aware, in the world. And a single functional failure can be the difference between life and death for patients. By undertaking risk analysis and manufacturing medical devices that are functionally safe, your company can benefit from increased market acceptance and positive brand associations. So designing with iWave system on modules, functional safety is taken care of since iWave has implemented a range of solutions provided by Xilinx and provides a path to test and integrate them to achieve the functional safety standards required by the medical products. So looking at the Zynq and Zynq MPSoC portfolio at iWave, we have system on modules ranging from the Zynq 7000, 7010, 14 and 20, and ranging from ZU4 all the way to the ZU19, and a single board computer which supports the ZU1, 2, 3, 4 and 5 variants of the MPSoC family. Looking at the MPSoC selection guide, right? So here we have integrated the B900, C784 and the C16760 package in our system on module, which provides you the scalability from ZU1 all the way to ZU19. Similarly, on the 7000 series, we have the CLG400 package integrated in our SOM, which provides you the capability from 7007, 7014 all the way to the 7020 series. So scalability of the iWave system on modules. So summarizing on how it helps solve your challenges on medical product design, the MPSoC architecture in a system on module provides a scalability from the ZU1 with 81K logic cells to ZU19 with the 1.1 million logic cell. So depending on the application, you have the complete scalability and options to choose one. The SOM also helps you solve the complex design challenges such as the IO banks handling or the high-speed DDR memory design. And building on economies of scale, we are able to target cost-sensitive as well as high performance and help you build the more cost-effective solution, which is more like buy or make kind of a decision which you need to take. And last is in terms of the product longevity and supply chain management through a system on module, which are also completely ruggedly tested and EMI EMC compliant, which can help you in your reliability tests and your regulatory compliance standards. The iWave systems also enables you with reference design for the system on module in the form of a development kit, which integrates the several FPGA IPs together with the associated IO ports. This allows you to develop your product concept on the reference board itself, eliminating the need for a complex high-speed design. The development kits ranging from the 7000 to ZU4 to the ZU19, it enables customers to quickly build your prototype to evaluate product marketing fit and evaluate performance across the different adaptive SoC options available. And these development kits are made ready to order, which you can receive within a short span of time, within a couple of weeks, to get started on your development journey. Now talking about a few case studies. So the first one being the requirement from a customer being an 8K image acquisition system, where they wanted to upgrade from a 4K image acquisition to 8K image acquisition system. So as you can see in the architecture, there was a requirement for two 8K cameras to be interfaced to our system on module, and the requirement for a temporary storage to handle the mismatch in the input and output data frame, where the NVMe SSDs acted as a frame buffer. And on the output side, the product was also connected to a host PC through a 10G Ethernet supporting the FTP protocol. And in the future, there's also talks of migrating the architecture or the algorithms on the host PC to the FPGA itself. So iWave did enable the customer with the 7CG system on module, building the complete carrier card design and enabling the complete NVMe SSD buffering through the PCIe channel. And iWave took the complete responsibility for the carrier card development, RTL development, and the Linux layer. Looking at the next application of high-speed, high-end medical endoscopy system with 4K support. So there was a requirement from a customer to build a solution with multiple input ports and multiple output ports. So supporting multiple peripherals such as HDMI, 3G SDI, and display port from the image sensors to the module, and the necessary support for multiple applications, since different hospitals have different monitors and different kind of processing systems. So they require support for HDMI, SDI, DVI, DisplayPort or LCD, and all of these simultaneously. So with the flexibility and customization on our system on module, we were able to support this customer with the support for multiple display ports, input ports, and output options to the customer. So similarly, we enable the customer with the design and development of the custom hardware and enable them with the real-time video capture and streaming through the flexible connectivity options on the system on module. And as of today's in today's scenario, there is a requirement for COVID imaging in seconds due to, like for example, in a mall or in terms of the airport where you want to screen patients rapidly. So that is where one of our customers is using the single board computer for COVID-19 detection in seconds. So complete peripherals such as the 10G Ethernet, the USB, and the HDMI enables the customer to create a high performance, accurate, reagent-free alternative for testing COVID. And one of the key factors here was the complete fast supply of these modules, where iWave, in spite of the supply chain challenges, was able to support this customer through a constant supply of these single board computers as per their required timeline. So over the years, iWave has enabled companies across the medical portfolio, starting from the handheld skin analyzer to the keratometer for eye testing, to the various diagnostic imaging solutions such as the CT imaging, patient monitoring through ventilators, or X-ray equipment. So iWave has enabled companies across the medical portfolio through our single board computers, system on modules, or the design services. Also helping companies, a few medical solutions is our Corazon-AI, or heart of AI, what it figuratively means. It's a scalable edge AI solution that can connect to 8 IP cameras and run multiple AI algorithms, such as your mass detection, or in terms of people counting, or social distancing. So the end solution can also help you in rapidly deploying solutions. The Corazon-AI integrates the complete software stack ranging from the Linux layer to the application stack and the YTC AI stack, which takes care of various AI frameworks and models. So it's a ready-to-use solution where you need not worry about the FPGA development or the embedded software development. So apart from the system on module, iWave also enables companies through the hardware design expertise, software design, IP core, or RTL. So so it can be a one-stop shop for customers across the globe in terms of the custom board design, or enabling companies through the complete software development lifecycle through their product lifecycle, or in terms of different IP cores like the video processing cores or your storage cores, or in terms of the different RTL designs like the VHDL, Verilog, and System Verilog. So iWave has built strong embedded FPGA expertise over the last 22 years, which you can leverage upon to build for rapid time to market with reduced development cost. So adding on to the previous slide, in terms of diagnostic imaging, iWave has built solutions and expertise over different types of video platforms, be it the MIPI camera, the SDI interface, or in terms of output ports such as the display port or HDMI. and with different types of resolutions like the 720p, 180p, and the 4K, 8K HD resolutions. So in addition to the system on module, different requirements also require different types of operating systems, be it Linux, VxWorks, or integrating the Xilinx YTCA stack on the platforms. So you have a multitude of options available for you dependent on the requirements of the end platform. So as I previously mentioned, thermal simulation is a key consideration for mechanical product designs. So with a complete mechanical and industrial team taking care of heat sinks, heat spreaders, and fan sinks, with the complete thermal dissipation taken care on the enclosure front as well. So iWave can also enable you with the complete thermal simulation and mechanical design to suit the product requirements. And last but not the least is in terms of the production and certification. So over the last 22 years, iWave has built a strong certification ecosystem along with the likes of the Veritas or the Wipro labs, which can help in the regulatory and the ruggedness testing. And in parallel, also working with different types of semiconductor supply chain partners such as Arrow, Avnet, Future, and XLPoint, who can help in the sourcing and have a very strong supply chain team for manufacturing. And how is iWave different from our other competitors is through the like a key focus on four main business pillars. So the first one is in terms of timeline. So how do we leverage our expertise is in terms of providing you a shorter timeline for career board design and product design, which can help you in quick time to market. The second one is in terms of providing you turnkey solution, whether it's only SOM or in terms of SOM plus carrier card, different types of business models, which based on your end customer or your requirement or in terms of your strategy to go to market. And last but not the least is in terms of what I've been emphasizing is the strong supply chain team at iWave, which enables you to combat and have a continuous supply of products. So as I mentioned on the previous slide, we are open for multiple flexible models. If you want to choose only the system on module, or you have a SOM plus custom board design, or only a software migration, we are flexible to adapt to your requirement. So here are a few resources such as the selection guide of the SOM or selection guide of the XILINX MPSoC. So we will pass along this slide to you, which you can use this for your reference. So thanks a lot for your time, and you can now shoot us questions through the chat window, which we'll be happy to answer.
Thank you, Taufik, for the wonderful. So now we'll jump on to
questions. So, Sheikh, there's a question from Kunal on what is the latest Linux version supported for the system on module or development kits?
Yeah, so our SOM-based development kit supports the Linux version 2021.1.
So, Kunal, the answer is that latest version of for the system on module and development kits, we support the Linux 2021.1 version for all our portfolio. And the next question for Sheikh, maybe Sheikh or Adi, if you can answer, is high density pins of SOM module. Does it support high speed interfaces like Ethernet? And I think these don't have IDLA support. So do you have some answer for that?
Yes, Taufik. Answer is yes. It supports the Ethernet, USB, PSGTR, high-speed PLGTR, in addition to HP and HP bank IOs. So we brought all the FPGA, PS and PL IOs to the SOM connector. So there is no restriction on that.
Yeah, I can add to that. Sheikh, are you able to hear me?
Yes,
Yes, Adi.
please.
Yeah, so it depends on what you mean by high speed. So if you want to do more than 1G or more, we can use the transceivers. So the transceivers should be also brought out to the SOM connectors, and you can use that on the carrier card. But if it's less than 1G and if you're using just the standard IOs, LVDS, you should still be able to achieve Ethernet connectivity. Many of our SOMs today we already have that, right, Sheikh? If
Yes,
you
yes,
can
yes,
confirm.
Adi. Yeah, thank you for your validation.
Sheikh, one more question for you. So, one of the slides you mentioned 100G Ethernet as a feature of the SOM. So, do we have any solution for 100G Ethernet?
Yes, actually, we already validated Xilinx 100G Ethernet along with ERNIC in our one of our development kit. So basically, that ERNIC is nothing but embedded RDMA enabled NIC IP used to achieve maximum throughput using the 100G Ethernet. So we do have that 100G solution using our SOM based development kit.
Sure, thanks, Sheikh. And maybe you can just stay online to answer another question from Rajesh. So, other than medical domain applications, whether other computer vision applications are supported, and what are the different types of interfaces available on the board for integrating cameras?
Yes, Rajesh. As it is, it's a FPGA, right? It's a field programmable gate array. So the iOS are always programmable. So it can be used for other vision-based application. It is not only restricted for medical application. So our standard development kit supports 12G SDA input and output, and HDMI 2.0 input output on the development kit. And we have two number of FMC connectors. So there are many off-the-shelf FMC modules are available for kind of MIPI cameras and other video interfaces. So by using that, we can support other cameras like USB, Ethernet, LiDAR, MIPI cameras, SDI cameras. So all sort of cameras can be supported using our SOM-based development kit.
Thanks, Sheikh. So I think we have addressed. So maybe anyone else from, okay, one more question from Samudra. So which interfaces are used for 100G Ethernet? Is it SDMII?
It is not SGMI, so 100G Ethernet. It's a hard block, comes along with the Xilinx Zynq MPSoC FPGA. So it is not, there is no external PHY required to convert the Mac to Mac and the PHY communication. So the PHY is part of the Zynq MPSoC FPGA. So no need to worry about the communication between Mac and PHY.
Thanks, Sheikh. So maybe just wait for a few more time while on questions. So while we wait for questions to pour in, Adi, I did see that you did mention about the AMD takeover of Xilinx and big news of the last 2 days. So do you want to throw some light on how it is going to continue on this FPGA offerings from Xilinx and what is the roadmap ahead?
Yeah, Tawfiq, can you hear me okay?
Yes, Adi, can hear you fine.
Yeah, I mean, today was incidentally the first day for Xilinx as an employee of Xilinx joining AMD. So day one, as we call it, and the commitment from the joint team has been to continue focus on the core markets group inside of Xilinx, right? And that includes the medical domain as well. Many of our customers, including medical and aerospace, have really long life cycles, and that expectation is there from Xilinx as well. So as of today, there is a commitment for many of these products to stay and even increase further for the core markets group, right? You must have seen a lot of interviews and a lot of articles even online where AMD has publicly mentioned this. So definitely there is a strong commitment for this market from the larger AMD group at the moment as well. I hope that, yeah.
Yes, Sari, thanks for that insight. So maybe one more question on Corazon-AI. So what is the operating temperature of Corazon-AI platform, and is it recommended for medical applications? So Ms. Sheikh, maybe you can just throw some light on how Corazon-AI can be used for a few medical solutions as well.
Yeah, definitely this can be used for medical application. So, especially the current situation, like mask detection, social distancing, using the AAML. So it can be used in a medical application. And to answer that operating temperature, so we have a complete Corazon-AI platform, including that enclosure, which can operate in the range of minus 20 to 60 degree.
Thank you, Sheikh. So we wait for a few more minutes in case any other participants have some questions on the Xilinx SOM, the Xilinx products. So a question from Rajesh, can you give some contact from Eastern India and whether the product is also available through GEM and what is the lead time for delivery? So yes, Rajesh, so we have a good distribution ecosystem partner in Excel Point. So I will connect you offline and we will also give you an idea of the availability on the GEM portal as well as the lead times. So I will drop you a mail offline connecting you through our distributors. So looks like there are no more questions. So thanks everyone for taking your time off the day to attending the session from Xilinx, iWave, Xilinx now AMD, iWave and Excel Point. And we will send you a copy of the slides and a recording of the presentation in the next few days. And in case of any questions, you can request you to take a screenshot of this slide and you can reach out to any of us for further information on Xilinx, SoCs, FPGAs, or the iWave system on modules, or further information on any of the products. Thank you. Have a great day ahead. Thank you.